Hiya. I'm just going to do a quick walkthrough of the dice rolls Python application, just to explain what it does and how it works. So first of all, let's run this a couple of times just to have a look. What it does is it wants us to decide on the size of a die. So it can be one, it can be a 6-sided die, a 4-sided, 20-sided, 100-sided, 1,000-sided, billion-sided, 53-sided die. I can do a 20-sided die, and I would find how many times I want to roll this. I can roll this a 20-sided die 20 times. And it gives me the random generated. So we're rolling a 20-sided die 20 times, and these are the results. The first die roll is a 2. The second one is an 18. The third one is a 20. The fourth one is a 5, and so on. We can do a 4-sided die and roll it 20 times. These are the random numbers that are generated. What it also does is it gives us the largest die roll of this, which is a 4, and the lowest, which is 1, and then adds them all together. And what it also does is it has a look at how many times each one of these numbers occur. So how many times did I roll a 2? Well, 11 times. How many times did I roll a 1? 4 times. How many times did I roll a 4? 3 times. And it has arranged them, ordered them by the largest number of die rolls, which is what I want. So let's do something simple. Let's run the die roll. I want to roll a 6-sided die, and I want to roll it 10 times. So 6-sided die, roll it 10 times, and then these are the results of those rolls. So a 3, a 4, a 1, a 3, 3, 2, 2, 3, 4, 2. The largest die roll is a 4. In other words, didn't roll a 5 or a 6. And the lowest is a 1. And together, the total is 27. So let's have a look how this code works. First of all, we have an import statement. We're importing the random library. Why? Because I want to use the random integer, random function, to create the random rolls. We could create our own random function. However, it's easy to use what's available to us in the library. So we're importing that because I want to use a function from it. Next, I define the two variables I'm going to use. In this instance, they're global variables, which generally is not a good idea, but for the sake of ease of use, this is what it is. We have the integer variable num size of dice is equal to 0, and with the integer variable num of dice rolled equals 0. How do we know they're integers? Because we define the zeros here are integers. And that's what I want. I want whole numbers. After that, we've created a number of functions. We'll have a look at these in greater detail, but we have the input dice function, the roll dice function, the statistics function, and the for lookup testa function. Define them all, and then down here is where we call them. So there are 4 functions then. The first thing we do is we call input dice. It has no argument, but it's asking for input. In this case, it provides us with these two. Please enter the number of sides to your dice, and please enter the number of times to roll this dice. And then the return statement provides me with 2 variables. Now I could call these spam and ham, bacon and eggs, pizza, pasta, doesn't matter. Well, it does matter. It's good to have names that make sense. And these names make more sense to me than anything else. So we're running the function input dice. Let's see what it does. So here we have the input dice function. You can see returns num size of dice and num of dice roll, and those are the values that I then store in these variables here. Now, what does this do? It does a number of things. First of all, encapsulate in a try except statement. Why? Because I want to make sure that if there are any errors in the entering of the information, I can catch that and let the user know, you've entered something that is not a number or a float or something that shouldn't be there, a text or whatever. So try running these 2 statements and see if there are any errors that occur. If errors do occur, I'm looking specifically for value error. In other words, if text is entered. That will print the statement to say, please enter only numbers, and then it will exit the program. So it will quit the program. And the -1 is just an error level. So I'm giving it an error level 255. What you notice is, if you look down at the bottom with most of the code that we run, it has process finished with exit code 0. 0 generally means all went well. Any other number than 0 generally means there's an issue. And I just happen to like using -1, which is going to give me an error level 255. But we can ignore that for the moment. So the important thing here are these two statements here. And you can see that I have the variables, num size of dice and num of dice rolled. So the first instance, we have an input statement, reading it from the inside out. Please enter the number of sides to your dice. So that's this statement here, and I've entered a 6. Now, the dot strip removes any white spaces, so tabs or space bars before and after the number, because I want just that number. The other thing is, if you remember, all input in Python is a string, but we don't want the string. We want the integer, the whole number. So therefore, we have to convert the string to an integer, and that's what it does here. And then, because I'm paranoid, it's possible to enter negative numbers, so -4 or -10 or -100. And what I'm doing is, if -4 is entered, I convert that to a 4. I want the absolute value. If -10 is entered, the value is 10. So it's just a way of eliminating some of the errors that can occur by the user entering silly data. Now, the input from that, in this case 6, is stored in the variable num sides of dice that we've defined up here. And we do the same thing then for the please enter the number of 6 to roll, the number of 6s to roll. Again, the same, we use a strip function, remove white spaces before and after the enter. We convert it to an integer, and I want the absolute value in case somebody enters a negative number. And so provided everything is okay and there are no errors, we have these two variables here that now have a value. This one has a value of 6, and this one a value of 10, as you can see down here, 6 and 10. And we return those values in this statement here. So let's go back down again. Input dice is executed. We return the two variables. Now these, I could have chosen different names, but I just like to keep things consistent. It's just easy for me to recognize what it is I'm doing. So that's a 6, and that's a 10, based on what we've provided here. Now the next function is called roll dice. And roll dice is passed 2 arguments. And the arguments are num size of dice and num of dice rolled. As we know, this is equal to 6, and that is equal to 10, because that's what we entered here, 6 and 10. And obviously we can see that something is returned. We'll have a look at that in a second. So we're executing this function with the following 2 arguments, a 6 and a 10. Let's have a look at that. And that is this here. Roll dice, num size of dice. So this, again, I could have x, comma y, a, comma b, ham, comma eggs, spam, comma ham. But it makes more sense to have these, call them the same. Because I can look at the function, I can say, roll dice, what does it expect? Okay, it expects a parameter of num size of dice and a parameter of num of dice rolled. So we have those two. Now I want to save these rolls. So whenever I make a roll, I'm going to save it to a list. So I create this empty list here that I call roll list. And for every roll then, we have a for loop. So it does a roll in range of num of dice roll. So num of dice roll is equal to 10. So in other words, for roll in range 10 from 1 to 10 or 0 to 9. And then what it does is it executes the random integer function. So remember, we imported the random library. As a part of the random library, we have the randint function. And what we're saying is we want a random number from 1 and the number of sides of dice. So we've entered 6. So please give me a random number starting from 1 to 6 and append that In other words, add that to the row list, the empty list. So let's say we now have this row list here. We rolled a 6-sided die 10 times. The first roll is a 3, second a 4, third a 1, fourth a 3, fifth a 3, sixth a 2, seventh a 2, eighth a 3, ninth roll a 4, and 10th roll a 2. What it does is it takes so this is what it does. It rolls the first time and it saves it to the list, the 3 in this case. That's what it does there. The second roll is a 4, it adds that to the list. The third one is a 1, adds us to the list. And then when it's done doing that, in other words, roll the 6-sided die 10 times, it saves it or returns it in roll list. So the roll list then, we've called the function and we have the roll list results. So I have that list there is in that variable that I just defined down here. So we've got input from the user, a 6 and a 10. We have rolled the dice based on the 6 and 10 that we entered. And we're now running the statistics function. That uses as an argument this variable, the roll list results, which is these numbers here. So let's have a look at statistics. So statistics does a number of things. We can see that it prints the roll list results, which is that. It largest dice roll, so uses the max function, takes the roll list, give me the largest number in this list. And the largest number is a 4. Because we didn't roll a 5 or a 6. And then it also gives us the minimum, so the lowest number that was rolled. The lowest number was a 1, so there we have the 1. And then the sum, it just adds all the numbers together. So basically take the numbers in this roll list and just add them up, sum them up. That's the easy part. Now, the next part is done so that we can do the added value calculation later on. And that is, to be able to do this, to figure out the value calculation, we give a value to a die roll as we roll 3 or more times. But to do that, we need to put it in a dictionary. Why a dictionary? Because a dictionary has a key and value, key value pairs. So the key in this case is a die roll. So it's a 1 or a 2 or a 3 or a 4 or a 5 or 6. And the value is a number of times that number has been rolled. And actually, what we're going to do is this. I'm just going to add a print statement here. Print, and we'll print dict rolls. I know that I also will want to print the tuple as well. So we'll print. There we go. Now, let's just do this again. So run dice rolls. I want to roll a 6-sided die, and I want to roll it 10 times. Now we have it slightly different. We have a 6, 6, 2, 1, 2, 5, 3, 6, 2, 5. The largest number is a 6. The lowest is a 1, and the sum is 38. Now this is interesting. Now, why do I want a key value pair? Well, because I want to see how many times did I roll a 6. Well, I rolled a 6 3 times. How many times did I roll a 2? Well, I rolled a 2 3 times. How many times did I roll a 1? 1 time. How many times did I roll a 5? 2 times. How many times did I roll a 3? 1. So that's what this does. And what it does, if we break it down, is we have the empty dictionary, and then it does 4 rows and roll list results. So the roll list results is here. So what I'm saying is, for every roll, for every number in this list, I want you to check, does the number exist in my dictionary as a key? So the first thing is, takes the number 6. Does number 6 exist as a key in dict rolls? No, it doesn't. So we go to the else statement. What we do is we say dict rolls 6 equals 1. So add the key 6 and give it the value 1. And then it takes the next number, which is also a 6. And it does, if rolls is 6 in dict rolls. Yes, 6 has already been added. So what do we do then? Well, to number 6, key number 6, that's what dict rolls 6 is, increment it, add a 1 to it. So it now has a value 2. Then it goes to the next roll, which is 2. Does 2 exist in my dictionary? No, it doesn't. Okay. Then we go to the else statement. So create. So what dict rolls 2 does here is adds the key number 2 and gives it the value of 1. Next is a 1. Does the same thing. Does a 1 exist in my dictionary? No. Therefore, I go to dict rolls 1. So creating the key 1 and giving it the value of 1. Then it goes to the next. So 1, 2, 3, 4, 5. That's number 2. Again, for 2 in roll list results, if 2 isn't dict rolls, and it is, because we have a previous 2 here, then I want to increase the value of that key 2 to add another one. That's number 2. That has a value of 2. Then we do the same with the 5 and 3, and then we get to the 6. So I'll just skip a few here. The 6 again, if 6 does exist in the dict rolls, which it does, because we already added it twice, or added added 2 twice, we then increment it with a 1 here. So basically the plus equal 1, what it does is it says take the value and add 1 to it, increment it. So that should now have the value of 3. I can see when that goes through the whole list, this is what we get. So we roll the 6 3 times, we roll the 2 3 times, we roll the 1 1 time, the 5 2 times, and a 3 1 time. And that's fine. And we could be happy with that and say that's enough information. However, we now want to sort it in by value order. So remember, we have a key pair. The key is a die roll. It can be a 6, 5, 4, 3, 2, or 1, because we've rolled a 6-sided die. It would be 10 if we had a 10-sided die, and so on. And the values are the number of times that we rolled each number. But I want to sort it by descending order by the highest value first. So a couple things here. I'm saving it to a tuple or a tuple, depending on how you want to pronounce it. The end result, and we can see that the end result is here. So I roll a 6 3 times, a 2 3 times, a 5 2 times, a 3 1 time, and 1 1 time. So it's actually sorted in the order of the highest value. Now, in the case that, for example, the 6 and the 2 both have a value of 3, I want to sort it by the highest die roll. Okay. So what we've done here is we're using the sorted function, and we've fed it our dict rolls items. So the dict rolls items are the key value pairs. And then we're saying sorted by key. And we use what's known as a lambda function. So lambda function is an anonymous function. And for example, statistics is not an anonymous function because it has a name, statistics. But here it doesn't, because we just want to do something quick and dirty. So what I'm doing here is saying I want to use a key value pair. I want to sort it by value first. So the highest value, the highest number of rolls. Secondly, the highest die number. So for example, if I roll a 6 3 times and a 5 3 times, I want the 6 to end up in front of the 5. But if I roll the 4, let's say 5 times, well, then I want the 4 to be on the top because the 5, the value is the highest. And reverse true, what I'm saying is I want to sort it in descending order. So that is what this does. And as we can see, the result here is sorted in order. And then we return that. So I'll just remove those statements because I don't want them. We return the tuple in right order, or tuple in right order. And we then save it as statistics tuple ordered results. Then we call the final function for loop catesta statistics tuple order results. So we're using that as an argument. There we have the parameter. And what it does is for value in statistics tuple order results. In other words, so this is a value, this is a value, this is a value, this is a value, and this is a value. And what we're doing here is we're saying for value in statistics. In other words, 0 value, 1, 2, 3, 4. Sorry. We want to print a statement, and we want value 0 and value 1. So what's this? Well, so first of all, the first value, or the 0 value here, is 6, 3. Value 0 here points to the 6, and value 1 points to the value 3. So sorry, the key 6 and the value 3. And then it goes through in a loop and gives me the values that I have here. And as we can see, sorry, it also does a calculation. So in this little piece here, I'll take the value, the 3, and I multiply it by 1,000. You can see that here. So dice roll 6, number times roll 3, points scored, 3 multiplied by 1,000 equals 3,000. And that's the end of that function. I should actually probably just have a return statement there to return nothing, but that would be probably the correct thing to do. So just to give you an idea of the thinking behind this Python code and the way it's set up, and I hope that gives you some ideas, better understanding of the application, and some ideas for the future. Okay, so with that, just want to say thank you and bye-bye.